An elephant can barely carry its own weight, but a leafcutter ant can easily hoist something 10 times heavier than itself. The ant's incredible strength is typically attributed to the physics of scaling, but there's actually another secret weapon that makes them super strong. They're exoskeletons. Hi, I'm Cameron, and this is MinuteEarth. Let's talk about scaling for a minute. Say you're a sheep, and you can just barely manage to lift this hay bale. If we took a shrink ray and shrunk you and the hay bale to a quarter of your heights, shockingly, you'd now be able to lift 4 of those hay bales. That's because you'd be relatively stronger than your prior self. As you got smaller, you'd lose weight faster than you'd lose strength. But you still wouldn't be as strong as an ant, because ants, as you've probably noticed, are not just shrunken elephants, sheep, or anything else. Large animals, like elephants, have relatively thick muscles and bones to counteract all of that mass, but ants don't need all that extra bulk. Plus, they have exoskeletons. First, an exoskeleton, whether on an insect, spider, or anything else that has one, provides large surface areas for muscles to attach to, so insects can have many smaller muscles working a single joint, as opposed to animals with internal skeletons which often just have a couple of big muscles at a single joint. What's more, exoskeletons tend to allow insects' muscles to be attached relatively far from the joints they operate, which makes using those muscles pretty low effort. However, internal skeletons often force muscles to be attached closer to those joints, allowing the muscles less leverage and requiring more effort. Exoskeletons also help insects breathe, which is crucial for keeping those strong muscles going. We have lungs that absorb oxygen and then load it into red blood cells that carry oxygen to our muscles. However, when our muscles are working hard, they can use oxygen faster than our blood can carry it. Thus, we get winded. Insects don't have this problem. Their abdomens are covered in little openings that connect to tiny snorkels called trachea, which allow air to directly oxygenate their muscles. So, if exoskeletons make animals so strong, why don't big animals have them? Well, passively getting your oxygen through your exoskeleton works just fine for smaller animals, but larger critters have so much more volume that oxygen can't passively penetrate deep enough into their bodies quickly enough. Essentially, an elephant in shining armor would suffocate. Also, exoskeletons can't grow because they have a non-living outer layer. They need to be shed. Because an animal's exoskeleton is basically its breathing apparatus, animals can't take in oxygen while molting those exoskeletons. That means that the bigger an exoskeleton-clad animal is, the longer it takes to molt, and the longer it has to go without oxygen. Which again means that a big animal would likely suffocate. While the exoskeleton provides a strength boost to tiny animals, it would handicap or even kill anything much larger than a mouse in most cases. And that's probably a good thing. Otherwise, we wouldn't be calling these ants, we would be calling them giants. Sharing our love for awesome science stories, geeking out about bugs, and working with awesome people is what we live for, which is why we are so excited that we got to collab with our fellow science lovers at Popular Science on this video.
This is Annie Colbert, Editor-in-Chief of Popular Science, and it was fantastic to work with MinuteEarth too. If you like this video and you want to dive even deeper into the exoskeleton rabbit hole, follow the link in the description to check out the other half of this epic collaboration on popsci.com.